Welcome students. Today we are going to explore an important topic in chemistry, chemical reactions and equations. By the end of this lesson, you will understand how chemical reactions occur, how we represent them with chemical equations, and the different types of reactions. Let's dive in. What is a chemical reaction? A chemical reaction is a process in which substances, called reactants, are transformed into new substances, called products. For example, when a candle burns, wax reacts with oxygen to form carbon dioxide and water. This is a chemical reaction because new substances are formed. But how do we represent such reactions? Chemical equations. We use chemical equations to represent chemical reactions. A chemical equation shows the reactants on the left-hand side and the products on the right-hand side, separated by an arrow. The arrow shows the direction of the reaction. For example, the reaction for the burning of wax is candle wax plus O2 gives CO2 plus H2O. This equation needs to be balanced, which brings us to the next important concept, balancing chemical equations. Balancing chemical equations. In a chemical reaction, the law of conservation of mass must be followed. This means the mass of reactants must equal the mass of products. To ensure this, we must balance the chemical equation by making sure the number of atoms of each element on both sides is the same. Let's take an example. Unbalanced equation. H2 plus O2 gives H2O. This equation is not balanced. To balance it, we adjust the coefficients. Balanced equation. 2H2 plus O2 gives 2H2O. Now we have 4 hydrogen atoms and 2 oxygen atoms on both sides. The equation is balanced. Types of chemical reactions. Now that we know how to write and balance chemical equations, let's look at the different types of chemical reactions. First, we have the combination reaction. Then there's the decomposition reaction. Next, we have the displacement reaction. Following that, we have the double displacement reaction. And finally, there's the oxidation and reduction reaction. Let's explore each type. Combination reaction. A combination reaction is when two or more substances combine to form a single product. For example, 2 hydrogen molecules react with 1 oxygen molecule to form water. Here, hydrogen and oxygen combine to form water. Decomposition reaction. A decomposition reaction is the opposite of a combination reaction. A single compound breaks down into 2 or more products. For example, when calcium carbonate is heated, here calcium carbonate decomposes into calcium oxide and carbon dioxide. Displacement reaction. In a displacement reaction, a more reactive element displaces a less reactive element from its compound. For example, when iron reacts with copper sulfate, iron displaces copper from copper sulfate to form iron sulfate. Double displacement reaction. A double displacement reaction occurs when 2 compounds exchange ions to form new compounds. For example, sodium sulfate and barium chloride exchange ions to form barium sulfate and sodium chloride. Oxidation and reduction reactions. In an oxidation-reduction reaction, one substance gains oxygen, which is known as oxidation, while another loses oxygen called reduction. For example, when iron rusts, here iron is oxidized by gaining oxygen to form iron oxide or rust. Exothermic and endothermic reactions. Chemical reactions also release or absorb energy. In an exothermic reaction, energy is released in the form of heat. A common example is the burning of coal. On the other hand, in an endothermic reaction, energy is absorbed. A simple example of this is the melting of ice. Corrosion and rancidity. Lastly, we have 2 common effects of chemical reactions. Corrosion is the gradual destruction of metals by chemical reactions with substances in the environment, like the rusting of iron. Rancidity is the spoilage of food containing fats and oils due to oxidation. Recap and conclusion. Let's recap what we've learned today. Chemical reactions involve the transformation of reactants into products. We use chemical equations to represent reactions, and they must be balanced. We explored different types of reactions: combination, decomposition, displacement, double displacement, and oxidation-reduction. We also learned about exothermic and endothermic reactions, corrosion, and rancidity. Understanding chemical reactions helps us explain the world around us, from cooking food to rusting iron. That's all for today's class. Don't forget to practice balancing equations and identifying the types of reactions. See you next time.